Today we're going to be working on verifying an identity. um, and so you'll notice that with an identity, unlike simplifying, we actually have a goal to get go towards. So they're just saying that this whole thing, once simplified, should be sine squared, and we need to verify that that is in fact true. So I'd like you to pause the video here and try out these four. I'll show you the answer key here in a moment. Now let's get started. So typically these are simple enough that you don't have to work both sides. So when you see something like this, typically, again, with some patterns, notice that these two, they won't cancel it immediately, but if they did make it into a fraction, one of them is going to simplify very, very quickly. So let's go ahead and break them up. We have secant of theta over secant of theta minus cosine of theta over secant of theta. So instead of having a common denominator all in one term, they've broken up your term into now two of the same denominator. So this will be 1 minus, and we have cosine over secant. So this is really cosine of theta over 1 over cosine of theta. So when you get stuck, so once you've simplified, if you notice that there's any trig function that's not in terms of sine and cosine, we definitely want to make it so that it is. Now at this point, we want to fix up this term. You have a fraction in the denominator, so we're going to keep change flip. We have 1 minus cosine of theta times cosine of theta over 1. Bring those two cosines together. We get cosine squared of theta. This is acting very much like if we had x times x. We don't make 2x. Instead, we make x squared. When they are multiplied together, we're changing your degree. When we're adding them together, you change your coefficient. Now, we can at this point use a trig identity. So we have 1 minus cosine squared, which in a previous video, we talked about all of your trig identities. We have sine squared plus cosine squared is equal to 1. Now, what they've done is that they have taken this trig identity and manipulated it. It looks like it has then just been subtracted a cosine to the other side. So we get 1 minus cosine squared is equal to sine squared. So this whole thing is equal to sine squared of theta, which when we look, we have now matched that down below, sine squared of theta. So that, in fact, is correct. Now let's do the same thing with number 10. So again, we might want to break these up here. So we have cotangent, and actually even better, if you have cotangent and a secant next to each other, when we go to rewrite them in terms of sine and cosine, that's actually probably where I would want to start. We have times 1 over cosine of theta all over cosecant of theta. I might hold off on that one here in a second. But notice that your cosines will end up canceling. So we're left with 1 over sine of theta all over cosecant of theta is really just 1 over sine of theta. Now, if you have the same thing on top as you do below, that is automatically going to be equal to 1. But let's say you wanted to keep going. Let's say you didn't see that right away. You can keep change flip your denominator. So now you have sine theta above. And again, these will cancel, and you're left with 1. So both of these will be equal to 1, which is exactly what we get when we pull that down. So again, this one is in fact verified. Let's try it again over here. So you have 1 plus tangent squared over secant, So again, up top, if we haven't recognized this one before, this is another trig identity. So this just says that if we have 1 plus tangent squared, and if I were to derive it actually really quickly. So if we had 1 plus tangent squared, this identity is equal to what value? Well, this is equal to secant squared of theta. And again, that comes from a different video on how we derived your trig function here. So if we have 1 plus tangent squared, this is going to be equal to secant squared of theta over secant of theta. Now you have 1 on top, 2 on top and 1 below. So 1 is going to cancel with the 1 below. So you're left with secant of theta is equal to secant of theta. Again, correct. Nice. So now number 12. Now, number 12, we typically want to work with the more complicated side. That would be this side. Now, you can notice that this side, it does look a little bit unusual. So if you wanted to actually rewrite this one, instead of having 1 over cosecant, which cosecant squared is just 1 over sine squared of theta. Again, kind of keep change flip. We're hoping that this whole thing is equal to a sine squared of theta. So let's work towards that goal. Sometimes if they're not simple enough on this side, if it looks a little weird, we can go ahead and rewrite the other side, but perhaps we're going to see a 1 over cosecant of theta. So if we have something like this, it looks very much like a difference of squares. So when you go to FOIL, we should get 1 times 1, which is just 1. So 1 times a positive cosine is a cosine. And then if we do the same thing with the other, then we get negative cosine times 1. And then negative cosine times a cosine. We should get these middle terms to cancel. We get 1 minus cosine squared of theta is equal to sine squared of theta, which is in fact true, but let's again use your identity to get more comfortable with it. They've just taken your trig identity, sine squared plus cosine squared is equal to 1, and they've just subtracted out your cosine. So 1 minus cosine squared is equal to sine squared. So this whole thing is equal to sine squared of theta, which is true on the other side. So notice that we did in fact have to manipulate this side to make it a little bit more sets. There you go. All 4 have been verified. These are nice because you already know what you are trying to work towards, unlike simplifying where we're not given anything to work towards. So notice that this one would have reduced to sine squared, this one just to secant, and so forth.